motion in a straight line. Particle kinematics, the motion of a particle in a straight line, we want to know about discuss about this kinematics, this chapter. Before going to the kinematics, we must know about some basic terms, that is particle, body, rest, motion, path, distance and displacement. First we want to know about the particle. Particle means an object which has negligible dimensions. Next one, body, which has finite dimensions. Object which has finite dimensions. కొంత కొలతలు ఉంటాయి, సైజ్ ఉంటుంది, అటువంటి దాన్ని బాడీ అంటాము. అలా కొలతలు లెక్కలోకి తీసుకొని ఉపేక్షించదగ్గ ఉన్న కొలతలు ఉన్న దాన్ని పార్టికల్ అంటాం. When we take, how you differentiate this two particle and a body? For example, a body of size, for example, 1 meter, traveled 2 meters, for example. 2 meters. Then we call it as a body. Why? The dimension of this body, the size of this body is comparable to the distance traveled by the body. Now, for example, same body traveled 1 kilometer. For example, a body traveled 1 kilometer, same body of size 1 meter. Then we call it as a particle. We treat it as a particle because the size of an object or a body which is negligible compared to the size, distance traveled by the body. That is the difference between the particle and the body. Generally, we take it as a body when the distance traveled by the body is comparable to the size of the body. If the distance traveled by the body is very large compared to the size of the body, then we treat it as a particle. In that sense, we take it as a particle and a body. For example, we consider Earth is bigger in size. But if you imagine the universe, in the universe, Earth is a particle. We treat it as a particle. The dimension of the system is very high, very large. That is why we call it as a particle. Earth is a particle. In that sense, we use particle and the body. Next, rest. What is meant by rest? If a body is like this here, there is no change in position of a body with time. If there is no change in position of a body with respect to time, then the body is said to be at rest. If there is a change in position of a body, for example, with the time, after 1 second the body travels from this point to this point, then the body is said to be in motion. Generally, rest and motion are relative. It depends upon the observer. For example, if bus is traveling on the road, two persons are standing in the bus, another person is standing at the side of the road, on the ground. Now a bus is moving like this. They say A, B, C. The observer is named as A, B, C. For example, A is the rest for B, person B, observer B, and for C is in motion. That means same person, for one observer is at rest, for another observer is in motion. That is why rest and motion are said to be relative terms. సాపేక్ష పదాలు అంటారు, relative terms. సాపేక్ష పదాలు అంటారు. Next one, for example, motion. What is meant by motion? If there is a change in position of a body, then it is said to be motion. Rest. There is no change in position of a body, that is at rest. For example, there is a change in position of a body. It traveled in this one. This is the first position, A position, B, C. if we join the successive positions of a moving body, we get a path. Margam and a path. The line joining the successive positions of a moving body is called a path. Next, the total length of the path, this path is called distance. The total length of this path is called a distance. For example, what is meant by distance and displacement we are going to know now. Here distance, if a body traveled like this, A, C, B. A, B, C, this is the successive positions of a body. First initially at this position, and at this position. Now, this total length of the path is called distance. Delta S I say. What is meant by displacement here? In another way, this is the shortest path between the initial and final positions of a body. This is called displacement. What you call it as displacement. In another way, we define the change in position of a body without reference to the direction of motion. In which direction it is moving, it is not interested here. But the change in position of a body without reference to the direction of motion is called distance. In another way, displacement. The change in position of a body in a particular direction. That is why we put an arrow mark there. Direction, arrowhead is kept on this line. The shortest distance between initial and final position of a body, or the change in position of a body in a particular direction is called a displacement. Now we want to know about the difference between the distance and displacement. We see some examples. First one is, for example, a body traveling from A to B. Position A to B. Distance traveled, I say this distance is D. Distance is equal to distance traveled is D, I say. Here displacement, magnitude of displacement, here I say D also, here also D. This is the distance traveled, it is the displacement traveled. Magnitude of displacement is called delta R bar. Mod delta R bar. Next one, if a body travels from A to B and then returns to A, here the distance traveled is equal to D to D, for example. D and in this direction B. Total distance is equal to D. Now the displacement becomes 0. Why? What is the initial and final positions of a body? A. That means the shortest distance between initial and final position of a body is 0. Another way, we write it as delta R bar is equal to AB bar plus BA bar. That means AB, we change the order, AB, it becomes 0. Here we get a negative sign. We reverse the direction, we get the negative sign here. That is why the displacement is 0. 0 vector we get here. Mod 0 we get here. Now, if a particle moves along the circumference of a circle, from A, it starts from A and reaches A and completes one revolution. The radius of the circular path is R, I say. Distance traveled, delta S is equal to 2 pi R. Total length of the path is given by the circumference of the circle. Now mod delta R bar is equal to 0. Mod delta R bar is equal to 0. That means initial and final position of a body is A. The shortest distance between initial and final positions is 0. Here. Next one. For example, if a body completes half of the revolution along the circumference of a circle and reaches B, whose radius is R, like this, what is the distance travelled? Delta S. The distance travelled is delta S, represented by delta S. It is pi R, half of the circumference. Next one, delta R bar is equal to, here the shortest distance is, this is the shortest distance. It is nothing but 2R. Nothing but 2R. Next one, if your body completes quarter of the revolution, that means it is R, A to B, it travelled from A to B. Now the distance travelled is the total length of the path. That means delta S is equal to pi R by 2, half of the semicircle. Pi R by 2, or 2 pi R by 4 actually. It becomes pi R by 2. Next one, the line joining AB by a straight line, we get delta R bar. The direction of this displacement is from A to B, initial position to final position, delta R bar. Now, how you get this one? It is right angle triangle, it is side, this side, and this is the hypotenuse. Delta R bar mod is equal to root of R square plus R square, it becomes root 2 R. This is the displacement of that vector. Displacement. Here we must remember, distance is a scalar, displacement is a vector. Why? It has a direction also from initial to final position. The direction of that one is initial to final position. What is meant by vector and scalar? Scalar means a physical quantity which has only magnitude. This is the magnitude. Is called a scalar. Vector. What is meant by a vector? Vector. Vector means a physical quantity which has both magnitude and direction. Here it has a magnitude AB, is straight line path length, and this is the direction. It has both the magnitude and direction. Now another example, we want to discuss another example. For example, if a particle moving along the circumference of the circle and makes an angle theta at the center and moves from A to B, it means it makes an angle theta at the center. It is not 90. Other than 90, 180 and 360, 270. Other than this. For example, it is 60, I say. 60 degree. What is the distance travelled by the body and the distance travelled by the covered by the body? Distance covered by the body. It is the distance. It is in the form of a sector. It is also pi by 3 in radians. Sector, in the form of a sector. It is the length of the arc. Delta S is equal to R is the radius of the circular path and theta. This is the formula for distance travelled by the particle or a body. Is equal to R into theta. Theta must be in radians. Theta must be in radians. Now, we want to find out the displacement covered by the body. Displacement covered by the body. For example, if we join A and B by a straight line, we get a displacement. This gives the displacement. Now I bisect this angle. This is theta by 2. It is theta by 2. Here it is x, I say, it is x. It is r. We want to find out x value. In this triangle, this is one triangle, we take it sine value. Sine theta by 2 is equal to opposite side by hypotenuse. Opposite side by hypotenuse. Now, x is equal to r sin theta by 2. Now displacement here delta r bar mod is equal to 2x, x plus x, 2x is the displacement. It becomes 2r sin theta by 2. These are the useful formulas if your body is moving in a circular path. Now here given theta is equal to 60 degrees. Here we put r into pi by 3. Must be theta must be in radians. Pi r by 3. Now here theta, displacement delta r bar is equal to two r sin 60 by 2. It becomes r sin 30. It becomes 2r into sin 31 by 2 is equal to r. We get it. This is the formulas useful in calculating the distance and displacement in case of a body moving in a circular path. Now, for example, distance is always positive, displacement may be negative also. For example, if a particle moving along the x-axis, it is the origin, it is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. For example, it is particle starts from O, here O, I say it is P. P here starts from P and travel to 5 and then moves to 3. It is Q R. It is R. What is the distance and displacement covered by the body? For example, distance, total length of the path 1, 2, 3, 4. It is 1. 5 minus 1 is 4. 4, 1, 2, 3. 1, 2. 5 plus 4 plus 2, 6. Distance traveled is equal to 6 meters, for example, it is in meters. Next, displacement, delta r mod bar. Delta r bar modulus is equal to, it is plus, it is towards the right. It is towards left, it is moving towards left. Generally we take towards the right is taken as positive, plus 4 minus 2. It becomes plus 2 meters, plus 2 meters. Because it is a vector, it has a direction. It has a direction. That is why delta S is equal to 6, delta R bar modulus is equal to plus 4 minus 2. We get plus 2 meters, plus 2 meters. This is about the difference between distance and displacement. And also another example, generally we want to know, for example, a body is thrown vertically upward from the top of a tower. The body is thrown vertically upward from the top of a tower and reaches maximum height and then finally reaches the ground. For example, the distance traveled in the upward direction is x, then it falls x. For example, height of the tower is h here. Height of the tower is h. In the case of distance, x plus h, it becomes 2x plus h. That means total distance traveled by the body. The total length of the path, that is known as the distance traveled by the body. Delta r bar mod is equal to, generally it is taken, initial direction is taken as positive, other direction is negative, opposite direction is negative. X minus h. Here these two cancel. The total distance displacement covered by the body is minus h. That means it is opposite to the direction of initial motion. It traveled opposite to the initial direction of motion through a displacement minus h. Difference between distance and displacement. Okay.